Hello everyone, welcome to our JEE main session on units and dimensions. In this session, we are going to look at measuring instruments, specifically the vernier caliper and the screw gauge. Let's get started. The least count of any instrument is given by this formula. You can remember this. It's the main scale least count, which is the smallest measurement that we can do with the help of main scale. So for example, your standard ruler, the minimum length it can measure is 1 millimeters. 1 centimeter is divided into 10 parts and the minimum we can measure is 1 millimeters, as you can see here. So if you want to measure things more precisely, I need another instrument. The standard ruler will not do. So that's where a vernier caliper comes in. A vernier caliper has a better least count. That means it can measure objects that are even smaller than 1 millimeters. This is how a vernier caliper looks like. As you can see, there is a main scale. This is the main scale. These are the jaws of the vernier caliper. Okay, if you have to measure an object, you have to fix that object between these jaws. This, however, this entire shaded scale is the vernier scale. Okay, this slides over the main scale. It is movable. So we are focusing on the vernier caliper for now. Let's see what is the least count. How do we calculate the least count of a vernier scale? There are two ways in which we can do that. One formula which works for any instrument is this. Any instrument's least count is the main scale least count divided upon the division on the secondary scale. In this case, the secondary scale is the vernier scale. Let's calculate the least count using this formula. So least count would be equal to 1 millimeter divided by number of divisions on the secondary scale. Here the secondary scale is our vernier scale. How many divisions do you see on the vernier scale right now? It's 10. It's not necessary that every vernier scale, every vernier caliper will have 10 divisions on the vernier scale. It depends on the manufacturer. Some manufacturers may put 20 divisions there. Accordingly, the least count of that particular vernier scale will change. For this particular vernier scale, however, 0.1 mm is the least count, which we've calculated using this formula. Remember that this formula works for almost every instrument that we have. Another way of calculating the least count of a vernier caliper is by using this formula. Least count of a vernier caliper is given by one main scale reading or one main scale division minus one vernier scale division. This formula will also give you the least count of a vernier caliper. Well, one main scale division. What is one vernier scale division, by the way? One vernier scale division in terms of the main scale division. Let's find how much is this quantity, one vernier scale division. As you can see that 10 divisions on the vernier scale are coinciding with how many divisions on the main scale? 9 divisions, exactly. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can see that 10 divisions of 10 vernier scale divisions are coinciding with 9 main scale divisions, isn't it? So we can say that one vernier scale division must be coinciding with 9 upon 10 main scale divisions. Yes? Okay. So that means one vernier scale division can be substituted with this. So I'll write that here. This thing goes here. So I'll write 0.9 main scale division. Okay. Now 1 minus 0.9 main scale division becomes 0.1 main scale division. So this is the least count of our vernier caliper. 0.1 main scale division can also be written as 0.1 millimeters because one main scale division is 1 millimeter long. That's why. So we get the same formula, or we get the same least count from both the formulae, as you can see. From this formula also we got the least count as 1 millimeter upon 10, which was 0.1 mm. From here also we get the same formula. Okay, so remember these two formulae. First formula you can see on your screen. The second formula also I'll write down. The second formula is this. Least count, but this is only valid for a vernier caliper. Okay, right. Let's move on to the next concept. Once we know what is the least count of an instrument, how do we measure? How do we do measurements using such instruments? Here you can see there are two instruments shown. One is the vernier caliper and the second is the screw gauge. We'll look at the screw gauge later. For now, just focus on the vernier caliper. This is how we use a vernier scale. Okay, if we have to measure, let's say, the size of a bullet, okay, you keep that bullet here between the jaws of between the two jaws. One would be the jaw of the main scale, the other would be the movable jaw or the jaw of the vernier scale. Now when you do this, you will see some reading is coinciding with the main scale division. For example, here the sixth reading, or the reading marked 6, is coinciding directly with the main scale division. There is no gap, no displacement. Okay, it's coinciding directly with the main scale division. And there'll be only one such vernier scale division which will exactly coincide with one of the main scale divisions. Only one. So that helps us calculate the size of this bullet. To calculate the total reading or the final reading, this we're going to follow this. Okay, this. As you can see, the vernier caliper that we have here has a least count of 0.02 mm. As I said, different vernier scales may have different least counts. So here we have a vernier caliper from a different manufacturer, and it's already given that the sensitivity or the least count of this vernier caliper is 0.02 mm. How do we measure the length of a bullet using this vernier caliper? So the total reading or the final reading is given by this formula. Total reading equals main scale reading plus vernier scale reading, as you can see written here. Okay, main scale reading plus vernier scale reading. So let's see what the main scale reading is. Let me zoom this a little. As you can see here, the main scale reading is that part which comes just before the 0 of the vernier scale. If we start counting, 0, 1, 2, 3, 4, 5, 6. Okay, so 6 divisions on the main scale is our main scale reading. I hope it's clear how we calculate the main scale reading. The length of this bullet is definitely this much, plus some more. So let's get back. Main scale reading, it's coming out to be 6 divisions of main scale, and 1 division of main scale is 1 millimeter long. So 6 millimeter, that's our main scale reading. Now what can you say about the vernier scale reading now? Here's the important part. Vernier scale reading is given by the least count of this vernier scale multiplied by which division of the vernier scale is coinciding with any main scale division. So we have to look very carefully and find which division is exactly coinciding with any of the main scale divisions. You would see that almost all the other divisions are somewhat off from the main scale division. This division of the vernier scale exactly coincides with a main scale division. Now this division, which is marked 6, is actually the 30th division, because you can see between any two divisions there are 5 small divisions. So we write least count of this vernier caliper multiplied by 30, which comes out to be around 6 millimeters plus 0.6 millimeters, which is 6.6 millimeters.